So even if you
ओके ठीक है हेलो 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 चेक चेक 1 2 3 yes I'm live now hello 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 I hope so I'm perfectly audible and visible to all of you. Please let me know in the comment section. Hello 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 check 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 1 2 3
ठीक है हेलो हेलो हेलो
let me just like
हेलो
my
हेलो
screen.
हेलो हेलो चेक चेक 1 2 3
I'm always the first one to like my screen.
Yes, I'm live now. Hello, hello, hello.
ठीक है okay
I hope so I'm perfectly audible and visible to all of you. Please let me know in the comment section. Hello, 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 hello. Check, check, check. 1 2 3. Hello, hello, hello.
ठीक है okay great fine perfect so I'm perfectly audible and visible I hope guys ठीक है all of you please let me know in the comment section if I'm perfectly audible and visible to all of you. Welcome to our session number 4 of the series that we had recently started for the NEET 2026 for physics, that too on this your lovely channel PW Gulf, right? And it's yes yes perfect I can see the chat section. Yeah no one has message there in the chat section. Great. Okay, great. So hello everyone, my name is Kunal Gupta and I welcome you all to Physics Wallah. चाय पी लो कहीं से, स्वाद मिलेगा यहीं से. Drink tea from anywhere, but you will get taste only from here. And to have the taste, we are starting with our fourth lecture of this series where we are discussing the question papers, the physics section of the NEET from 2005 to 2026, right? Those who are new to the session, let me just quickly brief you about the session. So please don't get confused. This smart guy in the photo, it's me only, right? So today we are going to discuss the question paper of 2008. Yeah, yesterday's video got a very good response. I was very happy seeing that, right? Make sure you share the link with your friends and family, right? Your relatives who are preparing for the NEET exam. Yeah. Oh man. Okay, those who are new to the stream, let me just quickly brief you on this PW Gulf YouTube channel. We have brought two series for you for physics. NEET NEET 2026. NEET 2026. First is the most important question series, of which I had already taken 4 lecture from diversified topics, and next is the previous year paper series. Fine. From 2005 to 2026. Okay. Now, those who are not aware, let me just give you a small brief. Earlier, this exam name was not NEET. It was All India Pre-Medical Test, AIPMT. Then once the paper got leaked, then they thought that, okay, let us change the name of the exam, right? Then they gave the exam name NEET, right? So that they can say, okay, NEET to hasn't been leaked ever, right? So they are saying that first time the NEET has been leaked. So earlier also it was leaked, but the name of the exam was AIPMT, All India Pre-Medical Test. Okay, fine. So All India Pre-Medical Test it was up till I guess 2015, right? And AIMS used to have its separate exam. Okay, AIMS used to have its separate exam. This AIPMT, you will find that from 2007 onwards, it was divided into prelims as well as mains. And I don't think so. Before that, it was pre and mains. So yesterday we had discussed a few questions of AIPMT mains exam as well. So they were quite good questions, and level of the questions were worth. Okay, and they were non-MCQ type. Okay, now this AIPMT then finally got replaced by National Eligibility Cum Entrance Test, which got leaked on 3rd of May. Fine. So please type in the chat section how is the Josh, low, high, dead, medium, alive, and let us begin with the session. Today we are going to discuss the question paper of 2008. 2008. 5, 6, 7 are done. Okay. So the next session would be of 2009 and we would be having it on Tuesday, Wednesday, Thursday, and Friday. Fine. So these days, and of course I will try that we have the session on next Saturday also. So 2010, 2011, 2012. Fine. But I will try 2013 was also done, but it is that we have to just prepare the lecture PPTs and the content, check the accuracy of the questions. Fine. So it takes some time. Okay. Earlier I was thinking to have a session tomorrow also. If you just be updated on the channel, if there is a session tomorrow, you can just join it. Alright, so first question on the screen, all eyes on the board related to units and measurements. So they are saying which of the following physical parameters have the same dimensions. Okay, for the first time when you saw, you would have when you saw this question, right? So you would say, okay, refractive index, speed of light upon speed of light in vacuum upon speed of light in medium. So this is dimensionless, fine, and even dielectric constant, epsilon, permittivity of the medium upon permittivity of free space. Okay, so both are there of them for the first time when you see they are dimensionless. Okay, and but B and C both are not in the option. Okay, let me just show it to you. So B is the refractive index, which is speed of light in vacuum upon speed of light in a medium. So refractive index represented by N has a dimension of M0, L0, T0. Okay. Coming to dielectric constant, capital K, permittivity of the medium upon permittivity of free space. Again, this capital K is also M0, L0, T0. Fine. So you would say, sir, okay, these two are having the same parameter, same dimension, but B and C are not in the option. That means you will have to check others also. Kids got confused. Okay, that means the options were wrong. No, you may have to check other options also and identify, okay, there may be other two pairs. Next is the energy density. That is energy per unit volume. Energy density. Energy per unit volume. Energy is ml square T minus 2. Volume is L cube. So this is ml minus 1 T minus 2. Next is Young's modulus. That is stress upon strain. Stress upon strain. Strain is dimensionless. Strain is dimensionless, but stress is force per unit area. Now this is dimensionless, so I'm not writing, but anyways, if you want, you can write delta L by L. So this is ml T raised to the power minus 2. That's good. So this will become how much? M L raised to the power minus 1, T raised to the power minus 2. Then is magnetic field. Magnetic field won't be matching with any of them. Reason being, force is equal to QVV. Fine. So magnetic field you will be getting force upon Q into V. Fine. So this will have some dimension of current also. Ampere would be there. As because that is the fundamental entity. So clearly you can see A and D are having the same dimensions. But is this in the option? Yes. Option number 4. Option number 4. Very good question to confuse you, right? Because when the kids saw it for the first time, they were like, are the options wrong? The answer is no. You will have to check each of them. But yes, overall, I must say the paper was easy. This year, the 2008 one, the question paper was easy. See this. All right. Next question. If the error in the measurement of the radius of a sphere is 2%, Error in the measurement of sphere is 2%, radius of the sphere. So delta R by R into 100 is 2%. Fine. Then the error in the determination of volume of the sphere. Volume is how much? 4 by 3 pi r cube. Percentage error in volume है ना, delta v by v into 100 is equal to, this entire thing is a constant, delta r by r into 100. Fine. So whatever is the power here, you multiply with that power. Correct? So 3 into 2, you get it as 6%. Option number 3. I think there is some issue with the mic. Next. Okay. A lot many questions were direct formula based, that you have to just substitute the values and you will get the answer. Okay. And this is one of them. So they are saying the distance traveled by particle starting from rest. So u is equal to 0 meter per second. With an acceleration of 4 by 3 meter per second square. Fine. So they are asking what is the distance traveled in the third second. The distance traveled in nth second is given by u plus a by 2 into 2n minus 1. So in the third second they are talking about initial speed is 0, acceleration is 4 by 3. Six into 5 है ना. So you can just cancel it out. This gets cancelled out on 2. 2 into 5 by 3. 10 by 3 meter. 10 by 3 meter. 10 by 3 meter. 10 by 3 meter. Next. Anji, next question. Next question. Please let me know in the comment section. I'm just seeing the comment section if you guys are there. Okay, 6 people are watching. Okay, for other subjects, I will just confirm. If you need it for the other subjects also, please let me know in the comment section. We will arrange it. Okay. But yes, this paper had 3 of very good questions which you are gonna find tough to solve. Okay, not tough but slightly tricky. Okay, a particle moves in a straight line with a constant acceleration. Okay, if changes its velocity from 10 meter per second. Anji, so initial speed, they are saying that 10 meter per second. Final speed, they are referring to it as 20 meter per second. 20 meter per second. While passing through a distance of 135 meter, in t second, what is the value of t? Fine. So can I apply v is equal to v square minus u square is equal to 2as? Can I? S is the displacement, or 2ad I can write. Fine. I know they are asking time, but first I would be needing acceleration. See, I will find acceleration first. Then I can substitute in v is equal to u plus at. So time I would be getting it as v minus u upon a. And so I need acceleration that I can find from here. Square of 20 minus square of 10. Twice of acceleration, 135. 400 minus 100, 300 you will be getting. This is 135 into 2, 270 into a. So acceleration will be how much? 300 upon 270. Fine. So 10 by 9 meter per second square. Substitute here. Time is equal to final v minus u, 20 minus 10, 10. By acceleration is how much? 10 by 9. This gets cancelled out. Time is equal to 9 seconds. Fine, clear? Any doubt, any query? You guys can unmute and ask. Chaliye. Acha, okay, in a few questions, graphs and diagrams are not clear, so I will just redraw them. है ना? So the diagram looked like this. Okay, and they were saying there are three sections: A, B, C, and D. Okay. Fine. So they are saying that a particle shows a distance time curve as given in this diagram, the maximum instantaneous velocity. This is displacement time graph. If you are aware, slope of this graph, that is m, is given by dx by dt. Fine. And that gives you the velocity. Fine. So wherever slope would be maximum, velocity would be maximum. Wherever slope would be maximum, velocity would be maximum. Now, how do you find slope on a curve? Very simple. For example, you want a slope here. Fine. So you will draw a tangent. Fine. And theta with the x-axis, that is tan theta. More is the theta, or you can say more is the inclination with the axis, more is the slope. Simple as that. Fine. So just try drawing the tangents. One tangent here, another tangent here, another tangent here, another tangent here. Fine. So on all 4 points, draw the tangent and see which of the tangents is having the maximum inclination. Slope means ढलान. More is the ढलान, right? More is the slope, more is the velocity. है ना? Fine. So just find out which is having more slope. Clearly, this C is having the maximum slope. Because if you see this angle, this would be maximum. So C is having the maximum velocity. Clear? Yes. Moving on to the next question. Read this. Again, a good one. Read this. Okay. A particle of mass m is projected with velocity v, making an angle 45 degree with the horizontal. So there is a particle with a velocity v. This makes an angle of 45 degree. This is making an angle of 45 degree. Okay. Now, when this particle reaches here, this would be pointing in this direction and would be having the same velocity, would be having the same speed as it was here. Yes, you heard it right. So they are asking that with the horizontal, when the particle lands on the level ground, the magnitude of change in momentum will be. Okay. So first you should know, for example, you launched it with 10 meter per second. So it will strike with 10 meter per second only, and with this angle 45 degree. Fine. Okay. So one of the component would be here, another component would be here. Fine. So this V can be written as, this initial velocity can be written as V cos 45 degree. Oh, देखिए ना, Vx I cap plus Vy j cap. Yes or no? Vx is how much? V cos 45 degree, है ना? Or simply V by root 2. Vy will be how much? V sin 45 degree. Sin 45 degree is how much? 1 by root 2. So Vi finally you got it as V by root 2 I cap plus V by root 2 j cap. Fine. Vi. What about V final? Here. V final. Vx would be here, V cos 45 degree again. V sin 45 degree है, V cos 45 degree, V sin 45 degree है ना. तो velocity here again Vx I cap plus Vy j cap. But here see, this velocity along y axis, this velocity along y axis this time is along negative y axis. So you will have to put a minus j cap here. है ना. You will have to put a minus j cap here. V by root 2 I cap minus V by root 2 j cap. So a minus sign will come up here. A minus sign will come up here. है ना. So they are asking what is the magnitude of change in momentum? That is final momentum minus initial momentum. Final momentum is m v final minus initial momentum is m u initial. Yeah, v initial you can say. M you can take common. V final minus V initial. V final minus V initial. V final minus V initial. This is final. This is initial. Fine. So final minus initial. Final minus initial. Fine. Okay, let me just write it out. V by root 2 I cap minus V by root 2 j cap minus initial. V by root 2 I cap minus V by root 2 j cap. V by root 2 I cap, V by root 2 I cap gets cancelled out. Minus minus plus. Minus 2 by root 2 V j cap. This is the change in momentum. This is the change in momentum. Fine. If I talk about magnitude of change in momentum, okay, this is the magnitude of change in momentum. 2 mv by root 2. If you want, you can just rationalize this. Fine. Root 2 mv you would be getting. This will get cancelled out with this. Root 2 mv. Root 2 mv. Root 2 mv. Root 2 mv, option number 4. Clear, clear, clear. By the way, no need to do this entire thing. You know that this horizontal component will cancel out the horizontal component. No need to even write that out. Final minus initial when you do, है ना. So minus minus gets plus. Directly you should have added these components. है ना. Directly you should have added this component. But I explained in detail so that all of us are on the same page. Anji, yes. Please hit the like button and make sure you share the stream link with the kids who are preparing for the NEET exam. Okay, fine. Yes. King's grade. Please type in the chat section if you are there. And how is the Josh, low, high, date, medium, alive? And now they are saying there is a conveyor belt. Sand is being dropped on a conveyor belt at a rate of m kg per second. So how much sand is dropped? At a rate of m kg per second. Fine. The force necessary to keep the belt moving with a constant velocity v. Fine. So this is moving with a constant velocity v. This is constant. Remember this. This is an important thing. Now force required. Now force you know is equal to dp by dt according to second law. Fine. This actually force is equal to ma is not the original formula. Fine. This is applicable only in one of the conditions, not always. Fine. Actual formula is force is equal to dp by dt. Instead of momentum you write mv. Now you differentiate this and this. Okay. Separately. So you used to write m dv by dt, which is acceleration, plus v as it is dm by dt. Fine. Now they are saying that velocity is constant. dv by dt is constant. So this, sorry, velocity is constant. So dv by dt will become 0. Oh, rate of change of velocity. Velocity is not changing. By final minus initial, you can think like that. Now velocity is not changing. So this dv by dt entire factor will be 0. So this force is equal to v dm by dt. this m kg per second is dm by dt, rate of change of mass, है ना? How much mass is changing per second? M, capital M. So I will just write capital M here, V into M, mv Newton, mv Newton. Clear? Clear? Any doubt, any query? Again, this paper was easy to moderate, है ना? As I said. Okay, this is a good one. Okay, let me give you the diagram. 4 Newton force was acting here. 2 Newton force was acting here, and a 1 Newton force was acting here. This is 30 degree. Fine. And this was 60 degree given to us. Fine. I'm not sure of 100% sure whether this was the diagram or not, but yes, most probably something like this was there. Fine. So we are just approximating, okay, somewhat. Let us understand the concept, even if option doesn't match. So they are saying that 3 forces acting on a body. Okay. So here is the body. Here is the body, are shown in the figure. To have the resultant force only along y direction, the magnitude of the minimum additional force needed. Now, they are saying that, now suppose I am standing here, one force is acting here, another force is acting here, another force is acting on me. So multiple forces are acting on me. Now they want my net should be along y-axis only, that either I am moving in this direction or I am moving in this direction. Fine. Right? I should not move in left, I should not move in right, only in y direction. So that means net force along x-axis must be 0. Whatever forces are on this side equal the forces on this side. Fine. What do I mean by this? Let me just tell you. Let me break this into 2 components. Not the 2 components, only along the x-axis. So this will be 4 sine 30 degree. Correct. Let me break this 1 Newton. 1 cos 60 degree. See, this is 30 degree, this is also 30 degree, vertically opposite angle. Fine. So here another force would be there, 2 sine 30 degree. Correct. How much it is? Sine 30 degrees 1 by 2, so this becomes 2 Newton. Cos 30 degrees or 60 degrees 1 by 2, sine 30 degree 1 by 2 plus 1, so 1 by 2 plus 1, 3 by 2. 1 by 2 plus 1, 3 by 2 or 1.5 Newton. Fine. Fine. So they are saying that net force should only be along y-axis. It can be non-zero. Fine. There should not be any force along x-axis. There should not be any force along x-axis. But as of now, you are getting 2 Newton here, 1.5 Newton. So net 0.5 Newton would be acting in this direction. But you don't want it. You need to cancel it out. You need to cancel it out. So you will say, okay, I will apply another 0.5 Newton to balance this. So that net force along x-axis is 0. Again, a good question that was asked. Again, a good question. Next. Achha, they had asked a similar question on this multiple times. Those who had joined late, we are discussing AIPMT 2008. Fine. A lot of you would be like, sir, you had scheduled the series for NEET. What is this AIPMT? So basically earlier it was not NEET. The name of the exam was All India Pre-Medical Test. Okay. Fine. So easy question it is. So easy question it is. Now they are saying water falls from a height of 60 meter. Okay, this happens in dams. Height of the water is 60 meter. At a rate of 15 kg per second. So how much mass is falling? per second, 15 kg per second. Okay. To operate a turbine, the losses due to frictional force are 10% of the energy. How much power is generated by the turbine? Now, see, there is water at some height. That means this water is having some potential energy, and this can be converted to power, and this can deliver some power. How much power it can deliver? Let us see. mgh, okay, by T. What is power? Work done per unit time. What is work? This energy stored, mgh by T. So how much power is available? M by T is how much? 15. G is how much? 10. Height is how much? 60. Fine. So this much power is available. Solve this. 15 into 6, 90. 9,000 watt. This much power is available, but this turbine, this turbine, you are giving it power, and this turbine, nalayak ekdam, what it does, it wastes 10% of the power. They had mentioned कि losses are due to frictional force, इसने 10% power waste ही कर दी, frictional force के चक्कर में 10% waste कर दी, 10% waste कर दी. What is 10% of this? What is 10% of this? 9,000 का 10% is 900, minus 900 watt कर दीजिए. How much is delivered? 90% deliver. 90% की वैल्यू कितनी हुई? 8100 watt. 8100 watt divided by 1000, 8.1 kilowatt. 8.1 kilowatt. 8.1 kilowatt. Option number 2. Option number 2. Hello, Kamran. How are you? How are you? I can see you. Hi, Kamran. Hi, Kamran. Long time. Good one. There is a shell. Okay. Okay. A shell of mass 200 gram is ejected from a gun. Okay. So there was a gun. You can think like this. There was a gun from which a shell was ejected. From which a shell was ejected. Fine. How much was the mass of this shell? 200 gram or 0.2 kg? What is the mass of this cannon? 4 kg. Fine. By an explosion that generates this much kilojoule of heat. So there was an explosion nearby. There was an explosion nearby. There was an explosion nearby which carried an energy of 1.05 kilojoule. 1.05 kilojoule, or you can say how much energy it is having multiplied by 1000, 1050 joules. 1050 joules. Okay. The initial velocity of the shell is. Let us suppose velocity of the shell after the explosion is v1. I do not know how much is the velocity of this. Let it be v2. I do not know. But they are asking how much is the value of v1. Now, understand this. So what is the concept? This got busted, right? Or you can say ejected because of that explosion. So whatever was the energy of this explosion got utilized to give some energy to this shell and to the gun. The gun will not remain stationary after the explosion. No. Fine. It will move. Okay. ये भी move करेगी. तो जितनी भी energy थी इसको चली गई एंड इसको चली गई, सो बेसिकली यूटिलाइज हो गई इसकी काइनेटिक एनर्जी में एंड इसकी काइनेटिक एनर्जी में। क्या कहना चाह रहा हूं मैं, दिस ई गॉट यूटिलाइज्ड इन काइनेटिक एनर्जी ऑफ द गन प्लस काइनेटिक एनर्जी ऑफ द शेल, है ना। तो ई इज इक्वल टू हाफ एम, द स्पीड ऑफ दिस आई हैव टेकन इट एज v2 स्क्वायर प्लस हाफ मास इज स्मॉल एम v1 स्क्वायर, ठीक है। But I do not have any relation between V1 and V2. So first find that out. First find that out. Can I apply conservation of momentum? Yes. Initial momentum is equal to final. Initially they are at rest. Fine. So this is 0. M into V2 plus small m into V1. So can I write minus small m into V1 is equal to capital M times V2. So V2 from here you would be getting M times V1 by capital M is equal to V2. So I can substitute the value of this V2 here. Fine. Okay, energy value I will substitute later on. E is equal to half capital M. हाफ यू कैन टेक कॉमन, है ना, हाफ में बाहर ले लेता हूँ, v स्क्वायर v2 स्क्वायर, है ना, स्क्वायर ऑफ दिस m स्क्वायर v1 स्क्वायर बाय कैपिटल M स्क्वायर प्लस स्मॉल m v1 स्क्वायर, फाइन, स्मॉल m v1 स्क्वायर, हाफ आर टेकन कॉमन, m and m gets cancel out. Energy is equal to half m square by capital M. अच्छा, v1 square also you can take common from here, है ना. v1 square small m square by capital M plus small m. Right. Now start substituting the values. Start substituting the value. V value is how much? 1050 joules. 1050 joules. ठीक है. 1 by 2 is equal to 1 by 2 v1 square. Small m square, है ना. Small m square means 0.2 का square. चलिए लिख देता हूँ. 0.2 square divided by capital M, that is 4 plus small 0.2. Send it here. Send it this side. How much it will become? 1000, 2000, 2100, है ना, is equal to v1 square. Solve this. How much you are getting? 0.2 square 224 by 100, है ना. 0.2 into 0.2, है ना, 224 divided by 100 plus 0.2. 2100 is equal to v1 square, है ना, 0.01 plus 0.2. Fine. ठीक है, या फिर मैं ऐसे भी कर सकता हूँ. हाँ, रिमूव दिस डेसिमल, 10 comes up here, है ना. तो LCM is 100, है ना, multiply this 10, 20 plus 1, 21 will come here. Fine. This is more easy, है ना. So this 21 and this gets cancelled out. So V1 square, finally you would be getting 100 into 100, that is 10,000. So V1 you finally get it as 100 meter per second. 100 meter per second. Very good question. And calculation based. Again I am explaining. So there was this gun and the shell, right? There was a nearby explosion V2, because of which this came out, right? This came out. Okay. This is how a cannon works. Okay. This was carrying this much energy. So this energy, where it went? This energy, some of it went in the kinetic energy of the cannon or the gun. Some of the energy went in the kinetic energy of the shell. थोड़ी सी एनर्जी यहां चली गई, थोड़ी सी एनर्जी यहां पे चली गई. दिस इज नीट 2008 और AIPMT 2008. फाइन. तो काइनेटिक एनर्जी ऑफ गन प्लस शेल ये लगाया मैंने, बट आई डिडंट हैड V2. ठीक है, तो V2 मैंने यहां से निकाल लिया, V1 की टर्म्स है और वहां पे रख दिया और फाइनली V1 की वैल्यू निकाल ली. यस, हाँ जी, चार्ट सेक्शन में लिख दीजिए हाउ इज द जोश, यू गाइस आर एंजॉयिंग, हाँ मजा आ रहा है आप लोगों को, ठीक है। जस्ट होप कि दोबारा एग्जाम लीक नहीं हो जाए, आई कांट टेक दिस सेशन अगेन, आई ऑलरेडी टेकन अ क्रैश कोर्स एंड oh, the ratio of the acha CBSE board, it has opened the portal where you want to, if you want to challenge a question and get more marks hai na, so you can just go on the portal and apply for it. The ratio of radius of gyration for a circular disc and that to a circular ring, each of same mass and radius around, this is having mass m, radius r, this is mass m, radius r, around their respective axis. Now I is equal to mk square, I by m is equal to k square, so k you would be getting it as under root I by m, ठीक है, okay. अच्छा, what is the radius of guide, sorry, moment of inertia for a ring, mr square. What is the moment of inertia for this disc? mr square by 2. Fine, okay. Mass they are saying same है ना. अच्छा, this is the formula for radius of gyration, but they are saying mass is same, so k is directly proportional to root of I. Can I say k is directly proportional to root of I है ना. K of disc is to k of ring under root I of disc divided by I of ring. I of disc is how much? mr square by 2. I of ring is how much? mr square. mr square gets cancelled, 1 by root 2. Is this in the option? Yes, option number 3. Is this in the option? Option number 3. ठीक है. I hope you know what is radius of gyration. Radius of gyration. This is the distance of the axis from the. This is the this k is the radius of gyration is the distance of the axis where if you calculate the moment of inertia, you will get the same value as it would have been from the axis passing from COM. Okay. ठीक है. This is a good one. ठीक है. I will tell you both the ways. Okay. Yes. The chemistry का भी चाहिए. Okay, आयुष. I will just talk to the chemistry faculty if she can have a session. तो वो लगवा देंगे. Okay. Fine. कौन से ईयर का चाहिए आपको बता दीजिए. I will just talk to Vishali ma'am. तो क्या कह रहे हैं सवाल में है ना. A thin rod of length L and mass M is bent at its midpoint. तो यहां से आपने bend कर दिया into two halves. So it is bent like this. Fine. The moment of inertia of the bent rod about an axis passing through the bending point and perpendicular to the plane defined by two halves. Okay, just let me just explain this to you. Suppose length of this, acha, okay, just focus on this much rod, है ना? Focus on this much rod. Length of this will be L by 2, mass of this will be M by 2. Similarly, length of this will be L by 2 and mass will be M by 2, only of this much rod. Only of this much rod, okay? Now, imagine that there is an axis passing from here. There is an axis which is passing from here. What is the moment of inertia about this? What is the moment of inertia about this? है ना, ये एक rod है ना, like this, है ना. There is an axis passing through this, है ना. What is the moment of inertia of this rod about this, है ना. ठीक है, remember what is the moment of inertia of a rod about an axis passing through the end? That is ml square by, yes, that is ml square by 3 है ना? Yes or no? Yes or no? Yes or no? Fine. कहाँ गया? ठीक है, correct. Now just see, I can give you the directly the answer. So the direct answer would be basically whatever is the moment of inertia about this axis is the moment of inertia about this axis, है ना, यही होगा, है ना. देखिए, बट मैं एक्सप्लेन करके बता देता हूं, है ना. तो इस रॉड की वजह से ml स्क्वायर बाय 3 m बाय 2 l बाय 2 का स्क्वायर बाय 3, है ना. तो ml स्क्वायर 2 2 4 4 2 8 324, है ना. उसी तरह इसका भी आ जाएगा ml स्क्वायर बाय 24, है ना. ml स्क्वायर बाय 24, यू ऐड बोथ ऑफ देम, व्हाट इज द टोटल मोमेंट ऑफ इनर्शिया? Moment of inertia due to first one plus moment of inertia due to second one. ml square by 24 plus ml square by 24. Twice of ml square by 24. So this will give you ml square by 12. By the way, this is the same moment of inertia as if the axis would have been passing from the center of mass, or you can say the center of the rod. So directly you could have marked, अरे भाई see ना, you had just bended this portion. बाकी तो everything remains same. Again a good question. Fine. From laws of motion. Acha, this year they had asked a good number of questions from mechanics portion. That is what I had observed. Okay, sir, please increase the speed. Okay, Ayush. Fine. A roller coaster ride is designed such that rider experiences weightlessness as they go round. Acha, whenever they had written weightlessness, so just write normal becomes 0. Fine, in the weightlessness situation. Okay. Around the top of a hill whose radius of curvature is 20 centimeter, the speed of the car at the top of the hill. Okay. So you would have seen as a roller coaster rides. You would have seen roller coaster rides, है ना? The car is coming, ऐसे ऐसे जा रही है. When it is at the top, when it is the topmost point, okay, they are asking what is the speed of the car. Now just analyze the forces acting on this. The normal would be there and the mg would be there. Imagine you are sitting inside the car, so mv square by r, the centrifugal force would be there. Correct? Imagine you are there inside the car, है ना? So you feel, okay, whenever you are inside a car, है ना, and you are there is a curve or a turn, don't you feel that someone is pushing you outwards, है ना? So outwards. So normal plus mg. Can I balance the equation? Now of course you don't want this car to fly up or get inside or move left or right, so that means these forces must balance out each other. Now they are saying, एक minute. Normal plus mv square by r is equal to mg. Fine. Now in weightlessness, normal becomes 0, so I am putting it 0. mv square by r is equal to mg. So m and m gets cancelled out. V is equal to root times gr. G is how much? 10. Capital R is how much? 20. So 10 root 2. Root 2 is how much? 1.414. So V you would be getting roughly 14.14 meter per second. Is this in the option? Is this in the option? No, this. So speed is between 14 and 15 meter per second. Are 14.4, 14.4 will be lying between these two now. These two. Okay. Those who have joined the session just now, we are discussing the NEET 2008 paper. You would be like, sir, अच्छा NEET तो होता ही नहीं था, आप कैसे डिस्कस करवा रहे हो उस टाइम? ठीक है, I know it was AIPMT ऑल इंडिया प्री मेडिकल टेस्ट, वही डिस्कस करवा रहा हूँ. फाइन. चलिए चलिए नेक्स्ट 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 वेरी सिंपल क्वेश्चन है ना. इफ Q, E and W denote first law of thermodynamics you have to apply, respectively the heat added, the change in internal energy and the work done in a closed cyclic process. Fine. Then in a closed cyclic process, that means in a closed cyclic process, so you started from somewhere and you had reached at the same point. This is the initial point and this is the final point. So internal energy, I know we write internal energy as U, but they had written it as E. Okay, what is the change in internal energy? That would be 0 because it is state function. From wherever you are starting, you are reaching there. Work done is a path function. Oh, again. For example, you started from here and you came back here. What is change in delta U? That is 0. Like it is similar to displacement. If you went all around and came back at the same point, the displacement is 0, correct? So delta U, change in internal energy is 0. So E is equal to 0, Q is equal to W. Here Q is equal to W, but they had mentioned it equal to delta U. So this is eliminated, this is eliminated. E is equal to 0, option number 4. Achha, wherever concept would be required, I will explain you. Very good Ayush. ठीक है Ayush, I hope speed is fine now. अभी speed ठीक है. एंड अपने फ्रेंड्स के साथ स्ट्रीम लिंक जरूर शेयर कर दीजिएगा जो भी नीट की एग्जाम की तैयारी कर रहे हैं. पीडीएफ यू विल फाइंड इन द डिस्क्रिप्शन. अच्छा, okay, these days it's very hot in India, है ना? It's very hot in North India, especially in Delhi, है ना? And 97 out of 100 hot cities are there in India, है ना? And if you see the newspaper or your mobile phone, they mention here temperature in, for example, it's written 31. They had mentioned 30 degree, है ना? So what is this 30 degree? Is it Kelvin? Is it Fahrenheit? Or is it degree Celsius? It's degree Celsius. Fine. When you go to the doctor, है ना? They put a thermometer inside your mouth and they say it's a 100 degree, है ना? So it's not 100 degrees Celsius. In 100 degrees Celsius, so your entire body will boil, है ना? Fine. So it's Fahrenheit. So you have different scales, है ना? You have Celsius scale, right? You have Fahrenheit scale. You have Kelvin scale. You have Reaumur scale, है ना? And they can give any other scale from their choice also, as they had given in this question. What does the general formula says? Listen. Achha, every scale has a ice point and has a steam point. Ice point and steam point. Ice point where water freezes at 0 degrees Celsius it freezes. Steam point at 100 degrees Celsius it boils. है ना? Similarly, you have it here. You have it here 32 degree and 212 degree Fahrenheit. Okay. So you should remember this. What does the formula states? Formula says that temperature in one scale minus temperature of ice point in that first scale divided by temperature of steam point in first scale minus temperature of ice point in first scale is equal to temperature in second scale minus temperature of ice point in second scale divided by temperature of steam point in second scale minus temperature of ice point in second scale. So this is the general formula. 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 Fine. Now they are saying that on a new scale, है ना, which is linear, है ना, the name of the scale is W scale. The name of the scale is W scale. They are saying freezing point, or you can say the ice point, and the boiling point, or you can say the steam point. It's one and the same thing. Steam point or boiling point. It's 39 degrees Celsius and 239 degrees Celsius. Okay. What will be the temperature on the new scale corresponding to a temperature of? Okay, so next you had compare it with Celsius scale, है ना? And the temperature in the Celsius scale is given to you as 39 degrees Celsius. ठीक है. Ice point in this is 0 degrees Celsius. Steam point in this is equal to 100 degrees Celsius. Fine. Temperature in first scale is missing. Ice point, it is 39. I am substituting here. 239 minus 39. Second scale में it is 39 minus 0 upon 100 minus 0. T1 minus 39 upon 239 minus 39, 200. 39 upon 100. So two zeros gets cancelled out. T1 minus 39. Send it there. This will become 78. So T1 will become 78 plus 39. So T1 will be equal to how much? Add them up. 80, 40, 120, 170. Degree W scale. Fine. Is this in the option? Yes. Option number 3. Is this in the option? Option number 3. Clear? Any doubt, any query? Yes, Ayush, very good. You had got the answer. बहुत बढ़िया. Next. Those who are watching the recorded session, pause the video and try the questions at the home. Pause the video and try the questions at the home. ठीक है. Try this out. Tell me the option. अच्छा, ओके, आप कह रहे हो आयुष कि मैं एग्जैक्ट कैलकुलेशन आपको नहीं बताऊं और सिर्फ अप्रोच बता दूं. ठीक है, हम ऐसा भी कर सकते हैं. फाइन, कोई दिक्कत नहीं. बट आप टेंशन मत लो. आई थिंक हम लोग ट्रैक पे चल रहे हैं. अभी 50 क्वेश्चन ही करने. अच्छा, उस साल जो है 50 क्वेश्चंस थे, ये भी मैं बताना भूल गया. देयर वर नॉट 45 क्वेश्चंस, देयर वर 50 क्वेश्चंस. ठीक है आयुष, आंसर बता दो या अप्रोच बता दो जल्दी से. ठीक है, चलिए, बहुत ही आसान है. क्या कह रहा है, मैं अप्रोच बता देता हूं. ये तो सॉल्व भी कर सकते हैं. यू नो पीवी इज इक्वल टू एनआरटी. डेंसिटी इज इक्वल टू मास अपॉन वॉल्यूम. मास इज इक्वल वॉल्यूम इज इक्वल टू मास अपॉन डेंसिटी. तो वॉल्यूम की जगह मास अपॉन डेंसिटी रख सकता हूं. ठीक है, तो P बाय रो इज इक्वल टू एन एम इंटू आर टी. ठीक है. नाउ this entire factor is a constant, है ना. They are saying the value for the density for a fixed mass, है ना. So you had fixed the mass of the gas, है ना. तो number of moles are also fixed. So you can say this P by rho is directly proportional to the temperature. Fine. They are saying at 100 degrees, at 10 degrees Celsius. 10 degrees Celsius mean 10 plus 273. So that will make it as 283. ठीक है. द रेशियो फॉर एन आइडियल गैस डिवाइडेड बाय, एक मिनट, द डेंसिटी ऑफ एन आइडियल गैस डिवाइडेड बाय प्रेशर. ओके, इट्स वाइस वर्सा है ना, तो रेसिप्रोकल लेना पड़ेगा. डेंसिटी ऑफ गैस डिवाइडेड बाय प्रेशर, दिस विल बी इनवर्सली प्रोपोर्शनल टू 1/T. तो यहां पे एट 10 डिग्री सेल्सियस आयुष ये क्या कह रहा है कि रो बाय पी की वैल्यू है एक्स. ठीक है, और वो पूछ रहा है कि 110 डिग्री सेल्सियस पे कितनी होगी. 110 प्लस 273, ये कितना आ रहा है, 383 केल्विन, है ना. केल्विन में ही रख सकते हैं इस फॉर्मूले में, है ना. यहां पे P बाय सॉरी रो बाय P की वैल्यू मैं मान लेता हूं कितनी है, y है ना. तो ये y की वैल्यू पूछ रहा है भाई, y की वैल्यू पूछ रहा है. ये सही यूश आंसर आया. तो x इनवर्सली प्रोपोर्शनल टू टेम्परेचर, है ना. ओहो, x इनवर्सली प्रोपोर्शनल टू टेम्परेचर 283, है ना. y इनवर्सली प्रोपोर्शनल टू टेम्परेचर 383. तो y की वैल्यू यहां से कितनी आ गई, 283 टाइम्स x डिवाइडेड बाय 383. दिस इज इक्वल टू 283 बाय 383. क्लियर क्लियर. नुमान, यस यस नुमान, एकदम सही एकदम सही. अगला सवाल, अगला सवाल. क्या देखते ही इसको बता सकते हो, देखते ही इसको बता सकते हो. टू डिफरेंट SHM इट इज टॉकिंग अबाउट. वन इज हैविंग an angular frequency of 100, another is having an angular frequency of 1000. ठीक है, अच्छा इसमें बहुत अच्छे सवाल आने वाले अभी. ठीक है, मैं इसके बाद एक टफ क्वेश्चन कराऊंगा. have the same displacement amplitude, है ना. तो दोनों का एम्पलीट्यूड सेम है, इसका एम्पलीट्यूड एंड इसका एम्पलीट्यूड इज बराबर. द रेशियो ऑफ देयर मैक्सिमम एक्सेलरेशन, एक्सेलरेशन इज इक्वल टू ओमेगा स्क्वायर इंटू एक्स. मैक्सिमम एक्सेलरेशन होती है एम्पलीट्यूड जब वो कवर कर रहा होता है ना. याद है, ये मीन पोजीशन है, दिस इज द एक्सट्रीम पोजीशन, दिस इज द अदर एक्सट्रीम पोजीशन. तो मैक्सिमम एक्सेलरेशन, मैक्सिमम एक्सेलरेशन, मैक्सिमम एक्सेलरेशन जब x सबसे ज्यादा यानी एम्पलीट्यूड के बराबर, ए मैक्स इज ओमेगा स्क्वायर एक्स. क्या पूछ रहा है, द रेशियो ऑफ द मैक्सिमम एक्सेलरेशन, a1 is to a2, ओमेगा 1 स्क्वायर a1 डिवाइडेड बाय ओमेगा 2 स्क्वायर a2. a1 a2 बराबर है तो कैंसिल हो जाएगा, ओमेगा 1 स्क्वायर है ना, 100 का स्क्वायर डिवाइडेड बाय ओमेगा 2 1000 का स्क्वायर. तो 100 बाय 1000 का स्क्वायर. टू जीरोस गेट्स कैंसर हो, 1 बाय 10 का स्क्वायर. 10 का स्क्वायर इज 100, 1 is to 10 का स्क्वायर. क्लियर. रेशियोज ऑफ द एक्सेलरेशन, रेशियोज ऑफ द एक्सेलरेशन. ठीक है, आ सकता है क्वेश्चन इस पे, है ना. डायरेक्ट है, बहुत ही आसान है. इलेक्ट्रोमैग्नेटिक वेव्स का कॉन्सेप्ट आप लगा सकते हो, है ना. EM वेव्स, वेव्स का सिंपली, है ना. तो द वेव इज डिस्क्राइब्ड बाय दिस इक्वेशन वेयर x and y are in meter and time is in second. Is a wave traveling along which direction. देखो पहले तो ये देखो, ये x लिखा है तो डेफिनेटली वेव इज मूविंग इन x डायरेक्शन, ये तो हमें पता लग गया, है ना. वेव इज मूविंग इन x डायरेक्शन. अच्छा, इसको आप कंपेयर करोगे y इज इक्वल टू a साइन kx माइनस ओमेगा टी, है ना. हाँ देखिए, अब अगर इन दोनों के साइंस आर डिफरेंट, है ना, इट्स प्लस माइनस और माइनस प्लस, है ना, इट्स आइदर वे प्लस माइनस और माइनस प्लस. ठीक है, सो वेव इज ट्रैवलिंग इन पॉजिटिव डायरेक्शन. अगर ये होता है ऐसे माइनस माइनस, या होता प्लस प्लस, तो वेव वुड हैव ट्रैवल्ड इन नेगेटिव एक्स डायरेक्शन, है ना. तो ये पॉजिटिव एक्स डायरेक्शन में ट्रैवल कर रही है, ये तो फॉर श्योर है. ठीक है, दिस ऑप्शन इज एलिमिनेटेड, दिस ऑप्शन इज एलिमिनेटेड. फाइन. अच्छा, अभी क्या कह रहा है, फ्रीक्वेंसी निकालने के लिए कह रहे हैं. फ्रीक्वेंसी ओमेगा, ओमेगा कंपेयर कर लो, ओमेगा इज इक्वल टू 2 पाई, ओमेगा इज 2 पाई इंटू एफ, 2 pi gets cancelled out, frequency is 1 hertz. पॉजिटिव एक्स डायरेक्शन विद 1 हर्ट्ज फ्रीक्वेंसी। वेवलेंथ निकालने की जरूरत ही नहीं है, ऑप्शन पहले ही बन गया है ना। तो एग्जाम में अपने स्किल्स, यू डोंट हैव टू शो योर स्किल्स, ओके आई एम गोना फाइंड लैम्डा आल्सो, नो नीड टू फाइंड, already you had got positive x-axis and frequency is different in both the options, so you had got the correct option through elimination also. Yes Ayush, again from oscillations, again from oscillations के बाद आई हैव टू, ठीक है इसके बाद ये करो होगा ना, बढ़िया सवाल था। जल्दी बताइए। x is equal to a sin omega t plus pi by 6, ठीक है। After the lapse of what fraction of time period the velocity of the point will be equal to half of the maximum velocity, ठीक है। अच्छा, पार्टिकल की इक्वेशन performing SHM is given by this. Can I differentiate this? Will I get velocity? Yes. Sin theta का differentiation is cos omega t plus pi by 6 into omega, है ना। V का इक्वेशन you had got it as a omega cos omega t plus pi by 6, fine, clear। तो V का इक्वेशन you had got now. What will be V max? V max will be equal to when equation of velocity you had got a omega cos theta, let us suppose. Now V will be maximum when cos theta is maximum. V will be maximum when cos theta is maximum, and cos theta can take a maximum value of 1, है ना। तो when this entire becomes 1 you will get V max, है ना, that is a omega, that is a omega, right? अच्छा, velocity becomes half of the maximum velocity, है ना। तो velocity becomes V max by 2, यानी a omega by 2. Let me substitute this in this formula. A omega by 2 is equal to a omega cos omega t plus pi by 6, ठीक है। a omega gets cancelled out, 1 by 2 cos omega t plus pi by 6. Now cos theta is equal to 1 by 2 at what angle? At 60 degree, है ना, 60 डिग्री पे आता है, नहीं cos pi by 3 cos omega t plus pi by 6. Cos and cos gets cancelled out. Pi by 3 is equal to omega t plus pi by 6. Send it here. Pi by 3 minus pi by 6. So you will get pi by 6 is equal to omega. Omega can be written as 2 pi by capital T. Pi and pi gets cancelled out. Send it here. Small, okay, capital T, send it here, by 12 is equal to small t. So as at this much time, the particle, after this much time, the particle acquires a velocity half as that of maximum velocity. Fine. Okay, very good Ayush. Ayush, how did you found it? यही method use करा था आपने? Please let me know. ओहो, पोजीशन की इक्वेशन दे रखी थी, डिफरेंशिएट करा, आई गॉट वेलोसिटी एंड हाफ ऑफ द वेलोसिटी, मैक्सिमम वेलोसिटी इज ओमेगा, हाफ ऑफ दैट विल बी ए ओमेगा बाय 2, तो वो यहां पे रख दिया एंड कैलकुलेटेड द टाइम। वेव ऑप्टिक्स, दो पॉइंट्स की बात कर रहा है, पॉइंट नंबर 1, पॉइंट नंबर 2, ठीक है। पॉइंट नंबर 1 इज एट अ लोकेशन ऑफ 10 मीटर, पॉइंट नंबर 2 इज एट अ लोकेशन ऑफ 15 मीटर। 10 meter and 15 meter, 10 meter and 15 meter, fine. Now from the source of oscillation, the period of oscillation is 0.05 second and velocity of the wave is this much, ठीक है। what is the phase difference between the oscillation of 2 points? phase difference पूछ रहा है, very simple, delta phi is equal to kx, k delta x, where delta x is the path difference, k is how much, 2 pi by lambda into delta x, delta x is how much, 5, now 15 minus 10, 5. Now what is lambda? Speed is equal to lambda into frequency. Lambda is equal to V by F. V is how much? 300. Frequency is how much? 1 minute. Oh, क्या पूछ रहा है, 1 मिनट, अच्छा लैम्डा निकालना है ना, अच्छा पीरियड ऑफ ऑसिलेशन इज गिवन टू यू 0.05 सेकेंड, तो यहां पर रख सकते हो स्पीड इज इक्वल टू क्या मैं रख दू, लैम्डा बाई टी, है ना, हाँ फ्रीक्वेंसी की टर्म्स में रख सकते हो लैम्डा इंटू एफ या लैम्डा बाई टी, ठीक है, ऐसे भी रख सकते हो, इट्स अप टू यू, फाइन। हाँ तो लैम्डा क्या आ जाएगा, स्पीड इंटू टी, स्पीड कितना है 300, टाइम कितना है 0.05, ये हटाओ डेसिमल, 20 कैंसिल हो 15, है ना, तो लैम्डा की वैल्यू 15 आ गई, यहां पे रख दीजिए 2 पाई बाय 15 इंटू 5, ये गया 3 पे, 2 पाई बाय 3, 2 पाई बाय 3, 2 पाई बाय 3, डायरेक्ट फॉर्मूला बेस्ड था कुछ इस सवाल में, नीट 2008, नीट 2008, नीट तो नहीं था, ऑल इंडिया प्री मेडिकल टेस्ट, बढ़िया से जल्दी जल्दी सवाल लगा के आओ, इसमें भी कुछ है, v इज इक्वल टू अंडर रूट म्यू नॉट इंटू एप्सिलॉन नॉट, है ना, सीधे सीधा वाला डायरेक्ट फॉर्मूला बेस्ड सवाल, गुड वन। हाँ जी, इंटेंसिटी क्या होता है, ये टू वेव्स है, टू सोर्सेज है, हम सॉरी, इससे जो वेव आ रही है उसकी इंटेंसिटी इज I1, इससे जो वेव आ रही है उसकी इंटेंसिटी इज I2, है ना, I1 एंड I2, I1 एंड I2, है ना, तो जो सुपर पोजिशन के बाद रिजल्टेंट बन रहा होगा उसकी इंटेंसिटी क्या होगी, I1 प्लस I2 प्लस 2 I1 प्लस 2 रूट I1 इंटू I2 कॉस फाई, क्या मैं ऐसा कह सकता हूं, क्या मैं ऐसा कह सकता हूं, यस, नाउ द सम ऑफ मैक्सिमम एंड मिनिमम इंटेंसिटी, अब इसको मैक्सिमाइज कर दो एक बारी मिनिमाइज कर दो, तो आई मैक्स क्या हो जाएगा, I1 प्लस I2 प्लस 2 रूट I1 इंटू I2, कॉस फाई की वैल्यू रख दो 1, ये मिनिमम क्या हो जाएगा, कॉस फाई की वैल्यू रख दो -1, ये -2 रूट I1 इंटू I2 हो जाएगा, ठीक है, द सम ऑफ मैक्सिमम एंड मिनिमम वैल्यूज, तो यू जस्ट हैव टू ऐड देम, है ना, आई मैक्स प्लस आई मिन पूछ रहा है, ऐड कर दूं, ठीक है, तो इससे ये कट जाएगा, है ना, ट्वाइस ऑफ I1 प्लस I2, ऑप्शन नंबर 2 1। क्लियर? एनी डाउट, एनी क्वेरी? कितना आसान था ये सवाल, है ना। ओहो, डायरेक्ट फॉर्मूला बेस्ड, 1 बाय फोकल लेंथ इज इक्वल टू 1 बाय F1 प्लस 1 बाय F2, ठीक है, ये 1 बाय F कुछ नहीं होता, पावर ही होता है ना, तो F2 प्लस F1 डिवाइडेड बाय F1 इंटू F2, लगा लो ऑप्शन। अच्छा, ये अच्छा सवाल है, ट्राई दिस आउट, दिस इज अ गुड वन। यस 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 यस, आयुष आई थिंक गलत मार्क करा आपने, है ना, पिछला वाला। अच्छा, इफ यू गो ऑन Y2 PW Gulf YT channel, in this live section you will find the recorded format like previous lectures which I had taken 2005, 2006, 2007 and today 2008. Fine, so you will find the question papers in the live section, you can just go there and check them out. Okay, this is AB. Fine, अभी देखिए समझिए, a boy is trying to start a fire by focusing sunlight on a piece of paper using an equiconvex lens of focal length 10 centimeter. The focal length of this is how much? 10 centimeter. Fine. The diameter of the sun is this much. Okay. So diameter of the sun, let us suppose this AB represents the diameter of sun, 1.39 into 10 raised to the power 9. ठीक है. And its mean distance from the earth is this much, है ना. And how much is this distance? That is 1.5 into 10 raised to the power 11. The lens of course is placed at earth only. Okay. Now, what is the diameter of the sun's image on the paper? So there is this boy, he has used a convex lens so that he can form the image of this sun. Okay. Let us suppose rays of light would be coming. ठीक है ना. तो from a object placed at infinity, the ray meets at the focus, है ना. All of us know that. So how much will be this distance where the image is formed? Of course, equal to the focal length, that is 10 centimeter. Fine. So they are asking how much would be this height of the image. Fine. How much would be the height of the image? Clear? Any doubt, any query? You guys can unmute and ask. Now you just notice this angular part, alpha. Can I say both are same? Though I can just directly tell you the formula, but I will give you the logic. है ना? Now here, in this tan alpha is equal to opposite side AB divided by adjacent side small d. Correct? And this tan alpha here is equal to opposite side upon adjacent side focal length. So HI will be how much? Capital D upon small d into F. Fine. So HI from here, can I calculate? Capital D is how much? 1.39 into 10 raised to the power 9 upon small d is how much? 1.5 into 10 raised to the power 11 into focal length, that is 10 centimeter. अच्छा, ये सेंटीमीटर को भी यू विल हैव टू कन्वर्ट इट इनटू मीटर बाय डिवाइडिंग इट बाय 100. Fine. Now solve this out, you will get the answer. 9, 10 zeros and this gets cancelled out. Okay. Height of image, remove this decimal, put 1 0 and 2 zeros. So this 1 0 and 1 0 gets cancelled out. है ना? So simply 139 upon 15 into 10 raised to the power minus 4 basically. है ना? 1, 2, 3, 4. है ना? So when you solve this, roughly you would be getting it as 5 point something. है ना? 5 into 10 raised to the power minus 4. Oh, sorry, 5 nahi. 9 into 10 raised to the power minus 4. Is this in the option? 9.2. Here, nearest. Fine. Clear. ये समझ में आया? एक बार ये बता देता हूँ. A boy is trying to start a fire by focusing sunlight on a piece of paper using an equiconvex lens. So I had taken an equiconvex lens of focal length this much. ठीक है. The diameter of the sun, they had given this much. Okay. And its mean distance from the earth is given at this much. Earth पे ही ये lens रखा है. अच्छा, you would have studied this also. Height of image upon height of object is equal to v by u. है ना? ऐसा भी कुछ पढ़ा होगा आपने. Height of image upon height of object is equal to v by u. यही लगा है. But I had told you the logic. How did I use this? है ना? तो rays आ रही है. Rays appear to meet. They would be meeting at focus. है ना? Fine. तो यहाँ पे इस ट्रायंगल में tan alpha लगा है. This upon this. In this triangle I had put tan alpha. This upon this. Simple, direct formula based. The energy required to charge a parallel plate condenser of plate separation D, area this much. Okay. You know that energy stored per unit volume. Half epsilon naught E square. Fine. Volume is A into D. Epsilon naught E square. So mu is how much? Half epsilon naught E square into AD. Option number 1. Hanji, clear. Yes, Ayush. Fine. ये तो डायरेक्ट फॉर्मूला बेस्ड था. Fine. This is A. This is B. This is C. This is D. Fine. And this is K. Fine. Hanji, yes. It's about to be 10 and 27 questions. Okay. Now they are saying that now you can just try that. A thin conducting ring of radius capital R is given charge plus Q. So plus Q charge is distributed on this entire ring. Okay. है ना? Plus Q charge is distributed on this entire ring. है ना? Plus 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 प्लस 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 है ना, यूनिफॉर्मली डिस्ट्रीब्यूटेड है ना. ठीक है. द इलेक्ट्रिक फील्ड एट द सेंटर ओ ऑफ द रिंग, सो दिस इज द सेंटर ओ. ओके. ड्यू टू द पार्ट ए की बी. ठीक है. ओनली ड्यू टू दिस मच पार्ट, only due to this AKB part. They are saying that electric field is how much? E, है ना? So it is positive. Of course, electric field would be in this direction. It is given by capital E. Right? Just think it. Imagine that a point charge is here, तो उसकी वजह से इस direction में है ना. The electric field at the center due to the charge on the part due to ACDB है ना. So they are saying भाई due to this much part, due to this much part, how much and where is the electric field? How much and where is the electric? What is the direction of electric field? देखिए, due to this entire ring at the center, net electric field is 0. Due to this entire ring at the center, net electric field is definitely 0, है ना? So due to this much part, it is E. Due to the leftover part, it must be E and it must be in opposite direction, है ना? So E along OK. Only then it will cancel out and the net electric field due to the entire ring will be 0. फिर से देखिए, at the center due to this charge ring, electric field is 0. All of us know, है ना? Equally distributed. Okay. Due to this much portion, है ना? Due to this much portion, है ना? Electric field is E in this direction, है ना? Due to leftover portion, it must be E in the opposite direction. This is a good one. Direct formula based, but still a lot of students got confused here. The one who will do this, they will get 10 rupees from me, है ना? 10 रुपए मिलेंगे ये क्वेश्चन करने के आपको, क्योंकि 10 बज चुके अभी. हाँ जी. The electric potential at a point in free space due to a charge q is this much. So in some free space there is some point p, है ना? Electric potential at this point p is q into 10 raised to the power 11. Okay. The electric field at that point, the electric field at this point p is how much? ये पूछ रहा है. Electric potential is this much, that is, अच्छा, electric potential at a distance r due to a charge is given by kq by r, q into 10 raised to the power 11. Q and q gets cancelled, k by r की value is 10 raised to the power 11. Okay. What is electric potential at this point? Electric potential at this point is k q by r square. अच्छा, इसको कैंसिल भी क्यों करना है? चलिए ठीक है, वैसे इट्स नॉट रिक्वायर्ड टू कैंसिल इट आउट, आप इसको ऐसे ही रहने दे सकते हैं, है ना? सो k कैपिटल Q by r, the value of this is q into 10 raised to the power 11, है ना? हाँ, anyways, so k capital Q by small r into 1 by r. Can I write like this? How much is the value of this? Q into 10 raised to the power 11. How much is the value of this 1 by r only? 1 by r is equal to, send this kq here, 10 raised to the power 11 by kq. Q and q gets cancelled out. 10 raised to the power 11 by k. 10 raised to the power 11 by k. K is nothing but 1 upon 4 pi epsilon naught, so that goes here. 4 pi epsilon naught into q into 10 raised to the power 22. Four pi epsilon naught q into 10 raised to the power 22. Option number 2. Fine. So the question was very simple, but kids were not able to reach the final answer, है ना? Final answer नहीं निकल रहा था बस. NEET 2008, better to say AIPMT 2008. जल्दी से डायरेक्ट फॉर्मूला बेस्ड, डायरेक्ट फॉर्मूला बेस्ड. डायरेक्ट फॉर्मूला बेस्ड. हाँ जी, जल्दी से कर दीजिए फटाफट से. हाँ जी, yes, this is direct formula based. Applications of in application of potentiometer we had studied this, है ना? internal resistance, a cell can be balanced against 110 centimeter, है ना? L1 is how much? 110 centimeter, and L2 is how much? 100 centimeter of potentiometer bar respectively, with and without being short circuited through a resistance of 10 ohm. Okay, it's internal resistance. So formula for internal resistance is capital R into L1 minus L2 divided by L2. Now here in exam, do not get confused ki sir what is L1, what is L2. The one which is bigger is L1. Simple as that. L1 is greater than L2. Okay. So small capital R is 10 है ना. 110 minus 100 10. L2 is how much? 100. सही कर रहा है ना? हाँ 10 upon L2 100. So internal resistance of 1 ohm it is coming. सही है, सही है, easy question है ना, direct formula based, direct formula based. Next सवाल, question number 29. 20 more to go, 20 more to go. 20 सवाल और करने हमें है ना, don't worry. I don't know आज ज्यादा टाइम क्यों लग रहा है, बट यस इवन इफ दे आस्क यू, यू शुड नो आयुष, है ना. चांसेस है, ऐसे तो रेडियो एक्टिविटी पे भी नहीं पूछना चाहिए था उन्हें सवाल, है ना, बट पूछा है ना. ठीक है, ओके. A wire of certain material is stretched slowly by 10%, है ना. ओ हलवा सवाल, so easy. Its new resistance and specific resistance will be. Specific resistance means, देखो, new resistance and new resistivity. Specific resistance means resistivity. So you stretch the wire, you compress the wire, you bend the wire, resistivity does not change. It does not depend upon the dimension. So this is eliminated, this is eliminated. Resistivity will remain same for sure. But yes, resistance will change. Only one, next option they are saying that both remain same. So by default, answer number 3. You did not even had to solve this. I can solve and show it to you, don't worry. But without even solving, but just by conceptual knowledge, okay, you know that, okay, dimensions you have changed, so resistance will change. Oh, देखिए ना, stretched by 10%. So new length is old length plus 10% of old length plus 10% of old length. 10 by 100, 110. L1. R dash is equal to N square into original resistance R. What is N? N is nothing but L2 by L1. That is 1.1. R dash is how much? 1.1 ka square into R. This is 1.21 into R. And to 1.21 times. Clear? Clear? So explanation is also there, but you need not to apply your entire skills. You just can easily get it. Diagram of this I do not remember at all, but I think it was something like this. ये रजिस्टर नहीं आ रहा मुझे याद कितने ओम का था. But we will do this. मैं एक बारी I will just check the diagram. What is the diagram of this? Okay, this is 4 ohm for sure. This was 3 ohm, and there were two resistors of 0.5 ohm. 0.5 ohm here and 0.5 ohm here. I do not remember how much it was. The circuit shows the current across 4 ohm is 1 ampere. When the points P and M are connected to a DC supply, this is point P and this is point M. Okay. The potential difference across point M and N. This was point N. Okay. I do not remember how much resistor it was. So let me just check and come back to this question in some time. See this. An electric kettle takes 4 ampere of 220 volt. Hanji, yes. अच्छा, मेक श्योर यू शेयर द स्ट्रीम लिंक विद योर फ्रेंड्स जो जो नीट की तैयारी कर रहे हैं दोबारा से री नीट 2026, है ना। तो प्लीज शेयर द लिंक. दिस इज अ सीरीज. आई विल डिस्कस द पेपर फ्रॉम 2005 टू 2026, है ना, पूरी सीरीज के अंदर. मेक श्योर यू ज्वाइन इट. चलिए देखिए, देर इज एन इलेक्ट्रिक केटल. Fine. It takes how much current? 4 ampere of current. Fine. At how much supply? 220 volt supply. Fine. How much time will it take to boil 1 kg of water? How much water needs to be boiled? 1 kg of water. Specific heat capacity of water 4.2 joule per gram per degree Celsius. Fine. Or you can just write 4200 in SI unit if you have to write joule per kg per degree Celsius. Fine. Okay. एक मिनट. From a temperature of 20 degree Celsius, you need to boil it, है ना. Boiling means 20 degree Celsius, 200 degree Celsius. So delta T becomes how much? 80 degree Celsius. Fine. The temperature of boiling, okay, they are asking how much time it will take. Okay. Okay. So you just find out that how much heat is supplied to perform this entire action. To perform this entire action, MC delta T, this much heat is required. Am I correct? MC delta T, oh, today is the temperature from 80 to 100 degrees Celsius, MC delta T, this much heat is required. And M is the mass, C is the specific heat, and delta T is the temperature. Okay. Now this current can supply this much heat in how much time? Let us see. Achha, how much energy it will supply? Power, you know, it is equal to energy by time. Achha, power is also equal to V into I. So energy is equal to VIT. VIT well load. So how much energy it has supplied in time T? VIT. Okay, so can I equate them? Yes, VIT is equal to MC delta T. So time will be equal to how much? MC delta T by VI. Let us substitute the values. Mass is how much? 1 kg. C is how much? 4200. Delta T is how much? 80. V is how much? 220. This is 4 ampere. So all this gets cancelled out on 20. 1010. This gets cancelled out on 11. So time is how much? That is coming 4200 divided by 11. है ना, this much seconds, है ना. So you will have to convert seconds to minutes also, है ना. You have to convert seconds to minutes also. So divided by 60, you will get it in minutes because options are in minute. 0 0 gets cancelled out. Time is equal to 420 by 66. Fine. Solve this. How much you are getting? Solve this. 5 6 something, है ना, 6.3 I think. Nearest it's 6 something आएगा, है ना. It would be 6 something, 360, 360, 396, हाँ 6 something आएगा. तो 6.3 minutes. ओके, मैं उसका डायग्राम लेके आ रहा हूं. Try this out. आयुष कौन से सी की वैल्यू बात कर रहे हैं आप? हाँ जी, ट्राई दिस आउट। आंसर आया क्या? जल्दी से चैट सेक्शन में बताइए। गॉट इट? चलिए, डन डन डन। ठीक है, वो डायग्राम आई हैड गॉट इट। फाइन, मिल गया डायग्राम। सी की वैल्यू 1 किस यूनिट में होती है? आई डिडंट गॉट योर थिंग आयुष। किस आइटम के लिए होती है, मतलब किस चीज के लिए होती है? दिस यू कैन आस्क आयुष। 1 किस यूनिट में होती है, ये तो अजीब ही पूछो आप। अच्छा, ओके ओके ओके, कैलोरीज वगैरह वाला पूछ रहे हो क्या आप? हाँ, ठीक है ठीक है ठीक है, वहां कैलोरीज आ जाता है। a current of 3 ampere flows through 2 ohm resistor, है ना? तो how much current is flowing through this? 3 ampere. Fine. Okay, the power dissipated in the 5 ohm resistor. So they are asking how much is power is dissipated across this. ठीक है, अच्छा, can I get potential difference across this? The answer is yes. Can I get potential difference across this? The answer is yes. Okay, how? V is equal to IR. Current is how much? 3 ampere. Resistance is how much? 2 ohm. So V is equal to 3 into 6, 6 volt. Fine. V is equal to 6 volt. Okay. So 6 volt, all three are connected in parallel, है ना? This branch, and this branch. So current across this branch will also be, sorry, potential difference across this branch will also be 6 volt. Acha, how much will be the current across this branch? This is 1 ohm, this is 5 ohm. Equivalent of them will be how much? 6 ohm. Fine. So current across this will be I is equal to V by R. R equivalent. V is how much? 6 volt. This is 6. 1 ampere. So how much current is flowing? 1 ampere of current is flowing. Now can I calculate how much is the power dissipated across this? Power is equal to V square by R, but I think we do not have V, so this formula is not of much use. So I square into R. I is how much? 1 ampere, 1 square. Resistance is how much? 5. So power is equal to 5 watt. Power is equal to 5 watt. Clear? Any doubt, any query? बड़ा आसान था ये तो। अगला सवाल, a particle of mass small m and charge q, है ना, having kinetic energy capital T enters a transverse uniform magnetic field B, है ना? तो सिर्फ magnetic field में लिखा है and work done by magnetic field is 0. I hope you are aware of that. ठीक है, तो जितनी पहले ओहो in magnetic field B, V does not changes, है ना? V does not change, that is the speed. ठीक है, so whatever is the initial kinetic energy is the final kinetic energy. So initial kinetic energy is T, finally also it will be T. Direct, है ना? छोटे से concept पे they had made this question. दिस इज अ गुड, अच्छा लूप था, आई थिंक ये था. A closed loop PQRS is carrying current is placed in uniform magnetic field. If magnetic force on the state PQRS ये था हाँ. If the magnetic force on PS, SR and RQR, PS, SR and RQ are F1 and F2 and F3 respectively. F1, F2 and F3 respectively. Fine. And are in the plane of the paper along the direction shown. The force on segment QP will be. Okay. What is the magnitude of force? Let us suppose force on this is F4. Okay. So what is the magnitude of force? F4. Fine. That is what they are asking us. Fine. Magnitude of force F4. Okay. Now, this is the basic rule that net force must be equal to 0. Whenever a loop is placed in magnetic field, the net force, not the torque I am talking about, the net force acting on it is 0. That is F1 plus F2 plus F3 plus F4 is equal to 0 and a vector sign. F4 will be equal to, or you can just write send F4 that side, F1 plus F2 plus F3 is equal to minus F4. Fine. Clear? You can write F3 has F3 I cap, F1 as this will become minus F1 I cap. This F2 will become how much? Minus F2 J cap, because it is pointing downwards. I cap minus J cap. Correct? Acha. Let me write it here. F1 is how much? Minus F I cap. F2 is how much? Minus F2 J cap. F3 is how much? F3 I cap is equal to minus F2. I cap ones with the I cap ones. F1 है ना? हाँ. So F3 minus F1 I cap can be taken common plus minus F2 J cap. This is it, minus F4. I hope you remember this, that suppose the vector is equal to xi cap plus yj cap. This is a good one. So magnitude of vector A will be under root x square plus y square. If z is also there, so plus z square. Hanji, you remember this formula or not? हाँ, तो यही कर दो. और वही पूछा था, द फोर्स ऑन द सेगमेंट एफ क्यू पी, द फोर्स ऑन द सेगमेंट क्यू पी, यानी F4 की वैल्यू इज व्हाट इट वाज आस्किंग, है ना. ठीक है. इसका F3 माइनस F1 होल का स्क्वायर प्लस माइनस F2 का होल का स्क्वायर. ठीक है. इज दिस इन द ऑप्शन? F3 माइनस F1 प्लस, हाँ ये रहा. ये माइनस का स्क्वायर तो प्लस हो जाएगा, है ना. फाइन. दिस स्क्वायर ऑफ माइनस विल बिकम पॉजिटिव. अच्छा, मेक श्योर you share the stream link with your friends. We had discussed the question paper of 2005, 6, 7 and 8 today. ठीक है. 9, 10, 11, 12 we will be discussing the next week, maybe tomorrow also. So just be updated on the, subscribe to the channel PW Gulf YT channel, and all the updates would be there on this channel. Okay. Next question. Direct formula based, just be careful while applying theta angle. What it is saying, क्या कह रहा है? There is a circular disc, है ना? There is a circular disc. Okay. And they are saying that radius of this disc is 0.2 meter. Fine. There is a uniform magnetic field of how much? 1 by pi. This is in SI unit. In such a way that its axis makes an angle 60 degree with the magnetic field. Okay. So this is the axis. By the way, this is the direction of area vector also. This is the direction of area vector also. This is making an angle of 60 degree with the magnetic field. Fine. The magnetic flux linked with the coil is, it's BA cos theta. BA cos 60 degree. Magnetic field is 1 by pi. Area is how much? Pi r square. Cos 60 degree is 1 by 2. Pi gets cancelled out. R square is 0.2 into 0.2 divided by 1 by 2. Gets cancelled out. 0.02. Option number 2. Option number 2, 0.02. Clear? Any doubt, any query? You guys can unmute and ask. Important. Good one. Try this out. Important question. AIPMT, or you can say NEET 2008. Okay. Try this out quickly. Take 2 minutes also to try this out, and I need a small washroom break for this. Nature's call. हाँ जी, yes. You guys got the answer. Answer आया क्या किसी का? Edits ना. You got the answer? Yes, Ayush Maurya, are you there? हाँ जी, नहीं. Third is not the answer of this. No. See. No. try to read the question, break the question into parts and then solve it, है ना? And I would say yes, it was a good question. And this is one of the few difficult questions asked this year, मतलब in this particular year. So there is a galvanometer. Let me draw a galvanometer. ठीक है. Having a resistance of 50 ohm. Okay, very good. Is connected to a battery of 3 volt. This is connected to a battery of 3 volt. ठीक है. Along with the resistance of 2950 ohm in series. अच्छा, okay. So there is a resistance of 2950. 2950 ohm in series. Fine. And a full scale deflection of 30 divisions is obtained in the galvanometer. In order to reduce this deflection to 20 divisions, the resistance in series should be how much? Okay. Right now, you had attached a resistance of 2950 ohm. Okay. Let us find out how much current is being drawn. Let us find out how much current is being drawn first. Current is equal to V by R equivalent. This is 3 volt. R equivalent will be 2950 plus 50. So 3000. V by 1000 ampere. This much current is being drawn. And they are saying it shows a full scale deflection of 30 divisions. It shows a full scale deflection of 30 divisions. So 30 divisions corresponds to 1 by 1000 ampere. Can I say that? Fine. Now you want this galvanometer to measure up to 20 deflections only, है ना? 20 divisions only. Okay. Now 30 divisions is corresponding to this much. One division will correspond to 1 by 30 into 1000. And 20 divisions will correspond to how much current? So basically with the help of divisions you have to find that how much current should pass through the galvanometer, है ना? That is what you need. So 20 by 30 into 1000. Now 1010 gets cancelled. So you can say they are saying that कि भैया that 2 by 3000 ampere. This much current. If you want only 2 by 3000 ampere current to pass. Earlier this much current was passing 1 by 1000 ampere. है ना? Now you want only 2 by 3000 ampere current to pass. How much resistance you should take instead of this? How much resistance you should take instead of this? ठीक है. Rest remains as it is, the galvanometer, and our resistance, let us suppose R. This is connected to 3 volt. So can I apply V is equal to IR? I dash R. This is 3 volt. Current is how much? 2 by 3000. Resistance is how much? R plus 50. So 9000 by 2 is equal to R plus 50. ठीक है. Sorry, by 2. So this gets cancelled out. 4500 है ना? 4500. Send this 50 this side. So this much is the resistance that is required. So how much? 4450 ohm. This much resistance should be connected if you want this much current to pass. Again, I will repeat. Very good question. It was option number 1. Hanji. Yes, all eyes on the board. So they are saying that when this was the circuit, it showed 30 deflections, or you can say this much ampere of current was passing. Okay. Instead of current, they gave us deflection. So from that I found the current. Now you want that this much current should not pass. This much current should pass. For that, this is a lesser value. For that you will have to increase the resistance basically, है ना. So how much resistance should have been there instead of this? The resistance in the series should be, है ना. To remove this, put some new resistance R, and now this much current is there. Put in V is equal to I dash R. ठीक है. क्लियर क्लियर क्लियर. तो कितना 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 रेजिस्टेंस होना चाहिए कि इतना करंट पास करे. Yesterday also we had seen above Curie's temperature, ferromagnetic substance behaves as paramagnetic. ठीक है. कुछ है इस सवाल में? डायरेक्ट फॉर्मूला बेस्ड, डायरेक्ट फॉर्मूला बेस्ड. N phi is equal to Li, है ना. 500 tons are there. In 1 ton, 4 into 10 raised to the power minus 3. Total flux, oh, total flux is equal to N phi is equal to Li. L is unknown. Current is 2 ampere. Gets cancelled out on 2. है ना. L you will be getting it as 1 Henry. Good one. What is the value of power, है ना, average power in the whole circuit? What is the value of average power? है ना. Again direct formula based. Average power VRMS into IRMS into cos phi, है ना. But is this in the option? No, this is not in the option. It is in terms of E0 and I0, है ना. This VRMS can be written by as V0 by root 2, IRMS I0 by root 2, cos phi. Now, V0 into I0 root 2 into root 2 is 2. एक minute. V0 is nothing but E0 here. So basically what happens in they are saying in phenomena of electric discharge through gases at low pressure, the colored glow in the tube appears as a result of, fine. So basically the electrons from the cathode, है ना, they strike with the atoms of the gas, and then a glow appears up there. Okay, because of that collision, है ना. So collision between charged particles emitted from the cathode and the atoms of the gas. In lot many places you will find the answer to be written as this, excitation of electrons, है ना. आपको कई जगह ये लिखा हुआ मिलेगा. हाँ जी, a good one. Now for this you should know all the wavelengths of all the electromagnetic waves in the spectrum, है ना. वो सारी पता होनी चाहिए. Try this out quickly. Jaldi. 30 seconds you are having. The class will go till 11 p.m. हाँ जी, जल्दी से निकालिए इसको, है ना. The work function of a surface of a photosensitive material is this much, है ना. वर्क फंक्शन कितना दे रखा है? 6.2 इलेक्ट्रॉन वोल्ट. I hope you remember the formula. Kinetic energy is equal to energy of the photon minus the work function. ठीक है. The wavelength of the incident radiation for which the stopping potential is 5 volt. So stopping potential दे रखा है 5 volt, है ना. अच्छा, जरा E से मल्टीप्लाई कर दीजिए. This will become 5 electron volt. ये EV0 is nothing but the kinetic energy. ये 5 electron volt. So 5 electron volt is equal to 6.2 electron volt minus, एक मिनट, अच्छा वेवलेंथ तो निकालनी है ना, तो एनर्जी इज इक्वल टू, एनर्जी निकालनी पड़ेगी पहले फोटोन की, पाई नॉट इज हाउ मच 6.2, send it this there, this side, 11.2 electron volt is equal to energy. Energy is nothing but 1240 by lambda. ठीक है, solve this. Lambda from here you would be getting it as 1240 divided by 11.2. Remove this, a 0 comes up here. Lambda will be how much? Roughly when you calculate this, 100 nanometer. And 100 nanometer corresponds to UV region. 100 nanometer corresponds to UV region, है ना. 100 nanometer corresponds to UV region. हाँ जी, यस. देखिए अभी चलिए नोट इट डाउन, कोई डाउट तो लेट मी नो. ठीक है, देखिए व्हाट इज द चीट कोड टू लर्न. गामा ने एक्सयूवी खरीदी, है ना. गामा ने एक्सयूवी खरीदी, है ना. गामा ने एक्सयूवी खरीदी. मिस्टर सी वाई सेड टू मिस्टर एक्स दैट यू आर वेरी इंटेलिजेंट मीडिया रेडियो पार्टनर, है ना, IMR. ठीक है, वी एक्सयूवी 700, है ना. एक्सयूवी कार आती है ना महिंद्रा की, IMR, है ना. गामा एक्सयूवी MIR. ठीक है, तो वेवलेंथ याद कैसे करनी है. दिस इज हैविंग वेवलेंथ लेस देन 0.01 नैनोमीटर. दिस इज हैविंग वेवलेंथ 0.01 नैनोमीटर से 10 नैनोमीटर. दिस इज हैविंग वेवलेंथ फ्रॉम 10 नैनोमीटर टू 100 नैनोमीटर. ठीक है, सॉरी 400 नैनोमीटर रहता है ये. 400 नैनोमीटर से 700 नैनोमीटर is roughly this visible spectrum. From 700 nanometer से 10 raised to the power 6 nanometer ये रहता है. From 10 raised to the power 6 nanometer से 10 raised to the power 8 nanometer ये रहता है. And greater than 10 raised to the power 8 nanometer. एनर्जी डिक्रीज हो रही है, वेवलेंथ बढ़ रही है, फ्रीक्वेंसी भी डिक्रीज हो रही है. राइट, क्लियर. सो बेटर यू लर्न दिस. सवाल पूछ सकता है ना. अगर आपको यही याद नहीं होगी तो कैसे पता लगेगा. कुछ नहीं तो एटलीस्ट विजिबल की इट शुड बी ऑन टिप्स, है ना. विजिबल की आपको याद होनी चाहिए. सो इजी क्वेश्चन, है ना. अब वॉट एवर इज द वेवलेंथ ऑफ दिस पार्टिकल, है ना, इज द वेवलेंथ ऑफ दिस, है ना. दिस इज 10 raised to the power 6. lambda 1 is equal to lambda 2, and if you know lambda is equal to h by mv, है ना, de Broglie wavelength. h by m1 into v1 is equal to h by m2 into v2, है ना. so m1 v1 is equal to m2 v2. ये आप कर सकते हैं. now let us come back to the question that we had left यहाँ पे, है ना. तो this resistor was of 1 ohm. Try this out. Try this out, please quickly. Try this out. Make sure you share the link with your friends, है ना. Those who are preparing for the NEET exam. ठीक है, try this out जल्दी से. I don't know why I'm waving my hairs, though they are not there at all. Okay. So you have to basically find potential difference between M and N, or simply you can say potential difference across this. ठीक है. Here they are saying that 1 ampere of current is flowing. Here they are saying that 1 ampere of current is flowing. Okay. ठीक है. हाँ जी. So what will be the potential difference across this? V is equal to I into R, है ना, 4 volt. इसके अक्रॉस भी इट विल बी हाउ मच 4 वोल्ट. ठीक है. अच्छा, दोनों पैरेलल में है ना, इन दोनों पॉइंट्स के अक्रॉस यू विल गेट द पोटेंशियल डिफरेंस 4 वोल्ट. इन दोनों पॉइंट्स के अक्रॉस भी यू विल गेट अ पोटेंशियल डिफरेंस ऑफ 4 वोल्ट ना, 4 वोल्ट. ठीक है. अच्छा, व्हाट इज द इक्विवेलेंट ऑफ दीज टू, दोनों पैरेलल में कनेक्टेड है एंड सेम रेजिस्टेंस इज देयर, तो R बाय 2 है ना, 0.5 बाय 2 या 1 बाय 2, तो 1 बाय 4. ठीक है. दिस इज 1 बाय 4 ओम, दिस इज 1 ओम, एंड ये दोनों सीरीज में कनेक्टेड है. Add them up, they will be having a 4 plus 1, 5 by 4 ohm. Right. And how much is the potential difference across this? 4 volt. Okay. What will be the current flowing in this branch? What will be the current flowing in this branch? 3 by R. 4 by 5 by 4. So 16 by 5 ampere. 16 by 5 ampere. So you know how much will be the, you know how much current is flowing across this, you know how much current is flowing across this. So V will be I into R. Current is how much? 16 by 5 ampere. Resistance is 1 ohm. This turns out to be 3.2 volt. Is this in the option? Yes, option number 1. A good one है ना. तो don't start finding the equivalent resistance. नहीं, 4 volt, 4 volt, 4 volt, 4 volt, equivalent, R by N. Fine. Find the current passing through this. The same current will, whatever current is passing here, है ना, across this branch, है ना, will be the current passing through this, because this is in series with this, है ना. तो current V is equal to I. Done. Yesterday we had done direct question, deleting it. Yesterday also we had done direct question, deleting it. Similar question yesterday. अच्छा, densities पे they are asking, मतलब radius पे और density पे they will ask. हाँ जी, density is independent of mass number. Density is independent of mass number. Density is independent of mass number. तो density, whichever nuclei it is, it remains 1:1, है ना. Derivation भी we had done. Yesterday only we had done, कल ही करा है सवाल, है ना. If MaZ, MP and Mn denote masses of the nucleus, mass of the proton and mass of the neutron respectively in SI unit, in units of U, sorry, and binding energy represents its and B represents its binding energy, right? Then which of the following is correct? ठीक है. तो binding energy you know, that is delta mc square. Delta m will be how much? Binding energy by c square. ठीक है. Now I have to substitute delta m, but one thing to is sure, c square is not in this, so this is eliminated. C square is not in this, so this is eliminated. So either this is correct or this is correct. What is delta m? Mass of the nucleus, and sorry, this is the mass of the nucleus and this is the mass of the nucleons. Now, कि nucleus का mass is m, ठीक है, a comma z. What is the mass of the nucleons, है ना. Z protons are there, Z into mass of one proton. How many neutrons are there? A minus Z. Mn. Mass of one neutron, Mn. ZMP plus A minus Z Mn minus M A comma Z is equal to binding energy by C square. Send it here. ZMP plus A minus Z Mn minus BE by C square is equal to M. Is this in the option? Yes, option number 2. Clear? Yesterday also we had done a similar question. Okay. Now it was directly they were asking you the binding energy. 3-4 more questions. ये तो we can just omit, delete it from the syllabus. ये भी हटा दो. अच्छा, see, diagram though is not clear to me, but I can just approximate. Okay, if it would have been, I'm not sure of the diagram. This is a NAND gate. Again a NAND gate. And यहाँ पे एक ये लगा होगा. ठीक है. I can just approximate it. I'm not sure, है ना, because the image is blur, है ना. So accordingly you just try to give the inputs, है ना. First give the input 0 0 and check what is the output, है ना. Then give 1 0, है ना, and then only give 0 0. This is A, this is B. Okay, no need to give all the outputs. Give 0 0, है ना, and give 1 1, है ना. उससे थोड़ा सा आपको idea लग जाएगा. If it is you have to confirm, then give 0 1 also, या 1 0. Very easy question. Anji, the class is about to end, bro. Fine. Okay, make sure you just hit the subscribe button and like it. Next session, either we would be having tomorrow or we would be having it on Tuesday. Tuesday, Wednesday, Thursday, Friday to are fixed. You will be having 4 sessions, so at least every week. 2009, 10, 11, 12. I would be discussing, and probably if you have class on Saturday, so 13 also. Okay, cool, fine. So be there. All the updates would be given on this channel. PDF you will find in that link, description link. Okay, fine. Oh bhai, how much is the band gap? 2 electron volt. The minimum frequency of the radiation required, hai na? Energy is 2 electron volt. So this much. So a PN photodiode is made of a material with a band gap of 2 electron volt. The minimum frequency of the radiation that can be absorbed by the material is energies H into F. Frequencies 2 electron is 2 into 1.6 into 10 raised to the power minus 19. H is how much? 6.6 into 10 raised to the power minus 34. 3.3. Roughly gets cancelled out on 2. Roughly. 1 by 2 is how much? 0.5 into 10 raised to the power 34, 19, 14, 15. Or 5 into 10 raised to the power 14. Clear. So here we come. Achha, tomorrow we would be, whenever would be the next class, just stay updated on this PW Gulf YT channel, है ना. Anji, so whenever we are having the next class, what I would be doing, I would be discussing 2009 ka paper, and prelims and mains both I would be discussing, है ना. So mains has some very good questions, है ना, that you will find very challenging to do, and trust me, in this series you will find your most of the paper is coming from this entire series which I am taking. Thank you very much for choosing Physics Wallah, and we would be meeting in the next class. Bye bye, see you. Any feedback, suggestion, please drop in the chat section and I will go through across this, है ना. Bye bye, see you guys.